So we are in dihydric alcohol, isn't it? So dihydric alcohol means compounds have two OH groups. How many OH groups? Two OH groups. Example is ethylene glycol. Ethylene glycol. So formula CH2OH bond CH2OH, isn't it? So ethylene glycol contains two primary alcoholic groups. There is no secondary alcohol. There is no tertiary alcohol. Clear? Now some important reactions. What's the IUPAC name of ethylene glycol? 1 to only 2 carbon. So 1 to ethane diol. Very good. 1 to ethane diol is the IUPAC name of this compound. Okay. We'll discuss some important 3 more questions. First, Bauyalt-Blanc reduction reaction. Bauyalt-Blanc reduction reaction. Bauyalt-Blanc reduction reaction. That's why we discussed, no? Yeah. That means the diethyl oxalate undergoes reduction reaction. We are using 8 hydrogen atom, isn't it? So diethyl oxalate means, what's the formula for oxalate? COOC2H5. COOC2H5. Named as diethyl oxalate. Diethyl oxalate. Okay, so reduction reaction. Reduction reaction means addition of hydrogen. Addition of hydrogen. Here we are going to add 8 nascent hydrogen atoms. 8 nascent hydrogen. Okay. So listen. Nearby carbon 2 hydrogen atoms. In nearby oxygen 1 hydrogen. Here 1 hydrogen. Totally how many hydrogen we used? 4 hydrogen. Very same manner. Here also 2, 3, 4. Clear? Now product is CH2OH, CH2OH. Glycol and 2 molecules of ethyl alcohol. So CH2OH and CH2OH, namely glycol, nothing but ethylene glycol, plus 2 molecules of C2H5OH ethyl alcohol. This is the product. Nothing but Bauyalt-Blanc reduction reaction. Very same thing. One more way also is there. From glyoxal. Glyoxal means CHO bond CHO. Glyoxal means what? CHO bond CHO. CHO bond CHO, namely glyoxal. Now, this is also reduction reaction. We are going to use 4 nascent hydrogen atoms. How many atoms? 4. Listen, mom. Here 1 hydrogen, nearby O 1 hydrogen. 2. How many hydrogen we use? 4 hydrogen atoms. What is the formula? CH2OH, CH2OH. CH2OH, CH2OH. We got glycol. That means ethylene glycol. Ethylene glycol. We can get ethylene glycol in one more way also, from glycolic aldehyde. From glycolic aldehyde. Glycolic aldehyde means CHO bond CH2OH undergoes reduction reaction. Here we need only 2 hydrogen atom. How many hydrogen we need? Only 2 hydrogen. 1 hydrogen nearby here, 1 more nearby oxygen. So it become a CH2OH, CH2OH, namely glycol, ethylene glycol. Clear? Nothing but Bauyalt-Blanc reduction reaction. The next question, explain the hygroscopic nature of ethylene glycol. Explain the hygroscopic nature of ethylene glycol. You know the formula of ethylene glycol. Hygroscopic nature. Hygroscopic nature of ethylene glycol. Ethylene glycol formula CH2OH, CH2OH, it contains 2 OH group, isn't it? So that it is able to form a intermolecular hydrogen bond. Intermolecular hydrogen bond. You know what is hydrogen bond? What is intermolecular hydrogen bond? Intermolecular mean hydrogen bond between the two different molecules. Two different molecules, isn't it? Intermolecular hydrogen bond mean international level, not only our nation. So here ethylene glycol contains two OH group. So easy to form intermolecular hydrogen bonding. Intermolecular hydrogen bonding. Clear? So this is one of the ethylene glycol CH2OH. CH2OH. Clear? Another ethylene glycol CH2OH. CH2OH. It's a two ethylene glycol. Clear? Now listen ma. Now where is hydrogen bond? This hydrogen bonded with this electronegative atom oxygen. Hydrogen bond is always denoted by dotted line. Okay, this is what hydrogen bond. So that ethylene glycol easily form hydrogen bond. That's why viscosity and melting point, boiling point, everything increases. Okay. So in ethylene glycol, when you add some amount of water or alcohol, it is easily soluble because water and alcohol everything form a hydrogen bond. Water OH, HOH, it form easily intermolecular hydrogen bond. Alcohol ROH, it form very easily hydrogen bond. But when you add ether, it is insoluble one because there is no way to form a hydrogen bond in ether. That's why ethylene glycol is soluble in water and alcohol because both are formed intermolecular hydrogen bond. It will break the polymeric structure. Which one? Water and alcohol break the polymeric structure. But ether does not. Why? Because ether does not contain hydrogen atom. There is no way to form a hydrogen bond. That's why ethylene glycol is insoluble in ether. This explains the hygroscopic nature of ethylene glycol. Clear? Okay. So ethylene glycol is soluble in water and alcohol, but not in ether because water and alcohol forms intermolecular hydrogen bond with glycol. It breaks the polymeric structure. Okay. But what about your ether? In ether there is no hydrogen atom. There is no way to form a intermolecular hydrogen bonding. So it not break the polymeric structure. Clear? This explains the hygroscopic nature of ethylene glycol. This is important 3-mark question. The next one is preparation of pterylene or degran. Pterylene. Or degran or pterine. Ethylene glycol reacts with terephthalic acid. Ethylene glycol reacts with terephthalic acid. It gives pterylene. Ethylene glycol formula. These are polymerization reactions. So ethylene glycol means CH2OH bond CH2OH. This is ethylene glycol. Ethylene glycol. These are polymerization reactions. Clear? So that you have to add n times, number of times. Ethylene glycol reacts with terephthalic acid. Terephthalic acid means one benzene ring contains two carboxylic acid COOH. This is also n times. Clear? Named as what? Terephthalic acid. Terephthalic acid. Listen. Now, always OH from acid. Okay. H from alcohol. So, removal of water molecule like this. Okay. Then one more water like this. Remaining acids you are going to write. That's nothing but pterylene. So, our product is CH2 bond CH2 bond O bond CO, then the benzene ring and COO. In product you have to add N in the end of this part. Okay. It's named as what? Pterylene or pterine or degran. plus 2n minus 1 amount of H2O will remove. That means removal of water molecules are no. That water molecules. How much water molecule remove mean? 2n minus 1 amount of water molecule. Clear? So how to prepare pterylene or dacron or pterine mean? Ethylene glycol reacts with terephthalic acid. It gives what? Pterylene. Clear? This is one of the 3-mark question. Next question. How to prepare ethylene glycol to ethylene? Ethylene glycol to ethylene. You know the formula for ethylene glycol? Ethylene glycol CH2OH. CH2OH. Now ethylene glycol to or glycol to ethylene. Like ethylene glycol to ethylene. Ethylene glycol formula CH2OH. CH2OH. Clear? This ethylene glycol reacts with PI3 phosphorus triiodide. Now these two OH groups are converted into iodide. So CH2I, CH2I. This is highly unstable compound. Why? This square bracket indicate highly unstable compound. Okay. Why? No. Because just think about halogen series. Halogen means 17th group elements are fluorine, chlorine, bromine, iodine. Astatine present in the 17th group, but that's not a halogen. That is radioactive element. Clear? So fluorine, chlorine, bromine, iodine, only 4 things only halogens. Why that is unstable? Just think about size of the iodine is very small or very large? Very big in size, isn't it? Comparing fluorine, chlorine, bromine, iodine atomic number is very high. So what about size of iodine? Very large size. Okay. Think about it. Why that is unstable? You know what is steric effect or steric hindrance? Already I told one story, you know. Steric effect or steric hindrance. Steric hindrance. This is a one bus seat. Okay. Maximum comfortably you can travel 2 persons. How many persons can travel? How many persons? Normal persons mean 2 persons can travel comfortably with long journey mean. Clear? Now normal persons mean. Now one bulky man is seated here mean. Okay. One more small child mean okay. One more bulky man. It's possible to sit in a single seat. Okay. What will happen? That's nothing but steric hindrance. Okay. Steric effect. Very same thing. Here adjacent carbon have very bulky 2 groups. Okay. So that's nothing but unstable. This is what very highly unstable compound. So what will happen here? See, removal of iodine. Removal of iodine. So this single bond combine here to make a double bond to form a CH2 double bond CH2, namely ethylene. Clear? You know how to prepare ethylene glycol to ethylene? Yes or no? Yes, sir. Okay. The next compound, how to prepare dioxane. How to prepare dioxane. It's very important for problem part. Ethylene glycol to dioxane. That is a ring compound. Ethylene glycol. That means for ethylene glycol to dioxane here. Okay. Glycol to dioxane. Ethylene, listen ma. CH2OH. CH2OH. I am going to take 2 molecules of ethylene glycol. How many molecules of ethylene glycol? 2 molecules. So I am going to write 2 times. CH2OH. CH2. What's the reactant name? Ethylene, or commonly you can say glycol. Okay. Reacts with phosphoric acid, orthophosphoric acid. Formula H3 PO4, H3PO4. You are going to heat the reaction, okay? Heating reaction. Listen, here there is a removal of water, because that is a dehydrating agent. So you will get one linear product, namely diethylene glycol. What is the remaining? OH, CH2 bond CH2. What's the remaining middle? O will come, then as it is. Okay, OH bond CH2 bond CH2, namely diethylene glycol. Diethylene glycol. That's a linear compound. But our aim is we are going to prepare dioxane from ethylene glycol. Clear? That's another step. In ethylene glycol, we are going to add concentrated sulfuric acid, because concentrated sulfuric acid is the best dehydrating agent. Clear? So, very same manner, we are going to add very same ethylene glycol, CH2OH, 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 CH2OH. I am going to add concentrated sulfuric acid. That's a dehydrating agent. Dehydrating agent means removal of water molecule. So you are going to remove the water molecule. Clear? So this O will come in the middle. So very same compound, diethylene glycol. Diethylene glycol means what's the formula? CH2OH bond CH2O OH CH2 bond CH. That is named as diethylene glycol. That named as what? Diethylene glycol. Now, diethylene glycol, again I am going to add concentrated sulfuric acid. Okay. Now, this side also I am going to remove one more water. Okay. So, this oxygen will come here. So, what's the product now? CH2 bond CH2O. Here also O will come in the middle. So, CH2 bond CH2 is named as dioxane. Now you got dioxane for ethylene glycol. Very important for problem part. Then oxidation reaction. You know the basic concept. Oxidation reaction means primary alcohol undergoes oxidation reaction, become a aldehyde. Aldehyde further undergoes oxidation reaction. Carboxylic acid is the product. Okay. Very same concept we are going to apply here. That is oxidation reaction. Okay. Initially I am going to take ethylene glycol. You know formula CH2OH? CH2OH. Ethylene glycol means CH2OH. CH2OH undergoes oxidation reaction. Oxidation reaction means one is addition of oxygen or removal of hydrogen. Okay. Here I am going to remove the hydrogen atom. So what's the product now? CH2O, CH2OH. You know very well. Primary alcohol undergoes oxidation reaction. What's the product? Aldehyde is the product. What's the product? Aldehyde is the product. Now again very same oxidation. So this primary alcohol converted into aldehyde, namely CHO bond CHO. CHO bond CHO. Again very same thing. This aldehyde further undergoes oxidation reaction. What's the product? Carboxylic acid and CHO as it is. Because aldehyde further undergoes oxidation reaction, what is the product? Carboxylic acid is the product. Okay. Very same thing. Here, this aldehyde undergoes oxidation reaction, what is the product? Carboxylic acid. The remaining acid is CH2OH. Now, this undergoes oxidation reaction. Acid as it is. Primary alcohol converted into primary alcohol undergoes oxidation reaction. What is the product? Aldehyde is the product. Okay. Then again undergoes oxidation. Aldehyde further undergoes oxidation. Carboxylic acid. COOH, COOH, namely oxalic acid present in where? Oxalic acid present in tomato. Yes. Then trihydric alcohol. Trihydric alcohols mean compounds have 3 OH groups. 3 OH group mean trihydric alcohol. Can you give one example of trihydric alcohol? Trihydric alcohol. Very good. Trihydric alcohol. Okay. That means compounds containing 3 OH group. Okay. So example CH2OH, CHOH, CH2OH, namely glycerol. IUPAC name 1,2,3 propane triol. 1,2,3 propane triol. 1,2,3 propane triol. Clear? Okay. Now this is one more question. Glycerol contains how many primary alcohols, how many secondary alcohols, how many tertiary alcohols? Glycerol contains 2 primary alcoholic groups, 1 secondary alcoholic group. How many tertiary alcohols? No tertiary. Okay. So glycerol contains 2 primary alcohols and 1 secondary alcohol. Clear? Okay. Now we will discuss some reactions. The first one is saponification reaction, very important reaction. Nothing but soap formation reaction. Soap formation, saponification reaction. Nothing but soap formation reaction. You know what is soap? What is soap? Daily we are using soap, no? How they are preparing soap? Any idea? Soaps are higher salt of higher fatty acids. Isn't it? Salt of higher fatty acids. What is the difference between soft soap and hard soap? Hard soap means that rain, power, that and all will come under hard soap. Okay. What is soft soap? Hammam, lac, that and all will come under soft soap. Clear? Okay. What is the difference between hard soap and soft soap? How they are preparing? Any difference? Okay. Triglyceric salt of triglyceric esters. Okay. Soap nothing but salt of triglyceric esters. Clear? So when you are preparing soap, if they are used sodium hydroxide, that's nothing but hard soap, tuning for a soap. They are using that potassium hydroxide, means that is soft soap, because potassium hydroxide is somewhat costly than sodium hydroxide. Clear? Okay. We are going to prepare now soap. Triglyceric esters. What is the formula for ester? COOR. COOR. Triglyceric esters. Okay. So listen, ma'am. So initially CH2, CH and CH2. Ester, COOR. For replacing purpose, I am going to write like this: OCOR. 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 Nothing but triglyceric esters. And now I am going to prepare only the hard soap. So I am going to add sodium hydroxide. Clear? So 3 molecules of NaOH, sodium hydroxide. 3 molecules of sodium hydroxide. Instead of writing 3, for you to understand here, I am going to write 3 times NaOH, NaOH, NaOH. Clear? Now RCOONA, removal of RCOONA, removal of RCOONA. What is remaining? CH2OH, CHOH, CH2OH. What is the product name? CH2OH, CHOH, CH2OH plus 3 molecules of RCOONA. Nothing but soap. Sodium salt of carboxylic acid, nothing but soap. Sodium salt of carboxylic acid, nothing but what? Soap. So during soap formation, a glycerol is a side product. Okay, this is glycerol. Okay, when you are preparing soap, glycerol is the byproduct. Okay, then very same thing we are going to prepare wax. Okay, instead of using sodium hydroxide, you are going to use water. You are going to use water and sulfuric acid steam. See, very same reaction. Triglyceric esters mean CH2OCOR, CHOCOR, CH2OCOR. Reacts with water only now. Water mean like HOH. 3 molecules mean 3 times HOH. 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 Reaction takes in presence of sulfuric acid and steam. Listen ma. RCOOH, carboxylic acid. RCOOH. RCOOH. What is the remaining? Glycerol. So CH2OH, CHOH and CH2OH. That time 3 molecules of RCOOH in the solid, you will get one solid and nothing but wax. Clear? So saponification reaction, first reaction alone saponification reaction. First reaction alone saponification reaction. The next important question here, synthesis of glycerol. Actually there is 3 mark question, but sometimes they are asking 5 mark problem. This alone they are asking 5 mark problem. Okay. In synthesis of glycerol, initially we are going to take propylene. Okay. Listen, we are going to use 4 steps. In first step, we are going to use chlorine 773 Kelvin. In second step, sodium carbonate 773 Kelvin, 12 atmospheric pressure. In third step, hypochlorous acid HOCl. In fourth step, NaOH. Okay, what is first step? Chlorine 773 Kelvin. Second step, sodium carbonate 773 Kelvin, 12 atmospheric pressure. Third step, HOCl. Fourth step, NaOH. Clear? So how to prepare glycerol from propylene on alkene? Okay. So first initially you are going to prepare from on alkene, namely propylene. Nothing but synthesis of glycerol, very important question. Synthesis of glycerol. Okay. So initially you are going to take propylene, nothing but synthesis of glycerol. Synthesis of glycerol from propylene. Propylene means CH2 double bond CH bond CH3, namely what? Propylene. In first step, we are going to add chlorine at 773 Kelvin. Okay. 1 H out of 3 hydrogen, remaining 2 hydrogen is present. 1 H, 1 Cl, removal of HCl. Okay. So here what you can write? CH2Cl. So CH2 double bond CH bond CH2Cl. Okay. Forget about Cl. CH2 double bond CH bond CH2 named as allyl. Named as allyl. So allyl have one chloride mean, namely allyl chloride. Allyl chloride. Now sodium carbonate and 773 Kelvin and 12 atmospheric pressure. 12 atmospheric pressure. Here actually hydrolysis reaction takes place. Okay, that means HOH, removal of HCl. So Cl converted into OH. Cl converted into OH. So CH2 double bond CH bond CH2 single bond OH. Now allyl alcohol. Allyl alcohol. Okay, followed by hypochlorous acid HOCl. HOCl. Cl. Now listen ma, here OH, HO, here Cl. Okay, so our product is CH2 bond OH. This will go here to make a bond. So it becomes a single bond CH Cl bond CH2 OH, namely glycerol chlorohydrin. Glycerol chlorohydrin. Glycerol chlorohydrin. Followed by we don't want Cl, we need only OH, isn't it? So we are going to add sodium hydroxide. Now Na and Cl, removal of NaCl. What is the remaining? CH2OH bond CHOH bond CH2OH, namely glycerol. Clear? So how to synthesize glycerol mean we can prepare glycerol from propylene. Okay. So propylene reacts with chlorine at 773 Kelvin to form allyl chloride. In allyl chloride we are going to add sodium carbonate 773 Kelvin and 12 atmospheric pressure. We will get allyl alcohol. Then allyl alcohol reacts with hypochlorous acid. It gives glycerol chlorohydrin. Then glycerol chlorohydrin reacts with sodium hydroxide. We can get easily glycerol. Very important 3-mark question, as well as they are asking problem part. Clear?